Hey everyone, my name is Shalin. I'm an SDs2 here at Plainsight. What Plainsight is, before we jump in details, is a platform for building, deploying, and operating real-world and real-time video processing pipelines. Customers use Plainsight to connect video streams like users RTSP camera feeds, apply AI models and filters, and run those pipelines reliably in production. One of the most important parts of that experience is the deployment. Essentially, when a customer creates a pipeline, they need to know not just that it was submitted, but that it's actually running and processing video such that Plainsight can do its inference on. This demo right now will focus on, at least from my side, how we've improved that experience by automating the deployment monitoring and updates. And then Sam will go into a little bit more on how the OpenFilter MCP demo attaches to all this deployment work. Specifically, what we want to do for my side of the demo is introduce a new deployment agent that owns the entire deployment lifecycle, from detecting new pipeline instances to deploying them, to then confirming that they're fully running. I'll start by explaining what we built under the hood, then I'll walk you through the end-to-end experience from a customer's point of view. So now looking at the slide here, we can see that this is about deployment automation, essentially deploying status tracking such that the system knows when the pipeline deployments finish. Previously, pipeline deployments were created successfully, but the system didn't know reliably when they finished. Once a pipeline had been triggered, there was no single component responsible for watching it through to completion. That led to instances getting stuck in a starting state, end-to-end tests not knowing when to proceed, and engineers needing to manually verify different deployments. To solve this, we introduced a new component, a dedicated deployment agent. This agent is new, and it's a critical part of the architecture. The agent runs as a continuous control loop, detecting new pipeline instances, filtering by instance ID to prevent duplicate deployments, and creates exactly one pipeline run per instance. From there, the agent actively monitors deployment progress. It watches pipeline run conditions and only reports completion when the pipeline that the user made is truly ready. When deployment completes, the agent calls a new API endpoint to update deployment and instance status in the database, closing the loop between infrastructure and the system state. Along the way, we fixed key reliability issues, including RTSP service configuration and duplicate pipeline run creations to make deployments consistent and predictable. The result that we see now is a fully automated closed loop deployment system with a clear owner. From a business perspective, this improves manual verification, enables end-to-end testing, and provides accurate deployment visibility. Now that we've covered what changed technically, let's look at what this means for customers using Plainsight. This slide shows the end-to-end experience for a customer deploying a video processing pipeline using our new agent. It starts when the customer creates a pipeline instance using the Plainsight UI or API. At that point, the system sets the instance status to starting. Behind the scenes, the new deployment agent immediately picks up that instance. The customer doesn't interact with the agent directly, but it now owns everything that happens next. The agent creates a Kubernetes pipeline run, which provides infrastructure, deploys processing pods, and connects to the customer's RTSP video stream. As the deployment progresses, the agent continuously monitors the pipeline and waits for clear signals that all components are running correctly. Once those signals are detected, the agent updates the system and the instance status is automatically changing the status from starting to running. This status change is visible in real time in the customer dashboard. There's no guessing, no manual checks, and no support intervention required. From the customer's perspective, the experience is simple, predictable, where we create a pipeline, watch it deploy, see it running, and start processing video. Compared to before, this provides faster time to value, clearer visibility, and much higher confidence that the system is working as expected. Ultimately, this makes Plainsight feel like a managed service where the platform handles deployment complexity so customers can focus solely on their video applications. And now what we're going to do is go into a little bit of a demo to show that part working. There isn't a fancy UI yet. That is the plan for the next coming weeks. But what we have now is the end-to-end deployment working on the terminals themselves. So I'll kind of walk through what I'm doing here one by one. The first step here is deploying a test script that has a test instance. This test instance will spin up a test video stream that is supposed to mock the customer uploading their own version of the RTSP video stream. So when this runs, it's going to run on a local Supabase URL, do a bunch of code here, start up the instance, spin up the video. And now what it's going to do is it's going to make the instance hang for about 10 minutes while the agent detects it automatically and then finishes deployment for the user without the user having to manually deploy Kubernetes and the pipeline controller. And so while the instance is hanging and it's waiting for the agent, we'll just talk through what some of this output means. So over here, we can see what the pipeline instance ID is. This is going to be unique to the user whenever they upload their own RTSP video stream that they have, which they now want to get deployed using the controller pipeline and Kubernetes. Over here, you can see that the pipeline instance is starting to be deployed, and it's not going to be finished until the agent says that it's done. Now, what we're going to do is start to spin up that exact instance. Right now, we have to specify it locally using the instance ID, but once this is pushed to production, this will automatically pull based on the newest instance that the user has uploaded, assuming that's the RTSP video stream that they want to use. So what we're going to do right now is go ahead and copy that instance ID and just paste it right here, such that the agent knows what instance to deploy and what instance to go off of. Once we hit enter, we get a really pretty output from the agent where the agent tells us what it's going to do: automatically deploy the server, ensure the pipeline's controller is deployed, wait for instances with the starting state from the end-to-end script, which is what you see here, and it will only process one instance at a time, create deployment records, create deploy pipelines, and then updates the instance status to running and Supabase table that this RTSP server is going to be hosted on, such that the script can end up finishing. What the script did in the background while I was talking was do just that. It updated the status of the instance that the user was running to running. The script was able to be deployed. The Supabase table is now updated with all these API endpoints added for the filter pipelines, the authentication, the videos, as well as the pipeline instances that we just ran. The agent itself has not completed running because it is now waiting for another API instance to run. And we can repeat the same thing if we just create a new instance using that same command, host it, deploy it, and add it to the Supabase table such that the user's RTSP video can now be processed and now be deployed safely. Over here, for each individual instance, we can see that this is the instance ID that we were able to provide it with. It says that we have a deployment record that already exists for the specific pipeline. That's because the agent was already able to deploy it. The pipeline run itself also exists, and we were able to deploy it, finish it, and then ultimately stop the instance in the Supabase table. And this is the first part of the demo, just automatically having something in the background that prevents the user from manually having to go through these deployment steps to deploy their RTSP video. That's what the agent does. And now I am going to hand it over to Sam to talk more about the MCP side and how the OpenFilter system interacts with the MCP demo.
Yeah, great. Thanks, Shalin. So many of those implementing technologies we just discussed are surfaced currently in a API that we use in our platform to, run the backend that creates all of the wonderful web UI that you can interact with in order to manage your infrastructure and your computer vision systems. With OpenFilter MCP, we were hoping to allow agents to assist with putting some time back in the day with handling this gut work of, say, if you wanted to do something specific in your platform, like create a new test case, you have some kind of regression in a production system, and you would like to run a new training in order to handle that. We didn't necessarily want you to have to click around. We wanted there to be an experience where you could use natural language to interact with all of this functionality without clicking around in the GUI, and even without leaving your editor. If you use MCP to interact with agents while you're building filters, you have code that you're working on, you have pipelines you're working on, we didn't necessarily want this to break you out of your flow. So if I could just share here. So what we have, so now previously with OpenFilter MCP, you could only do code search. Code search was something that we use a lot internally, and it's great if you're trying to build novel filters, but that's not necessarily something that customers want to do all the time. Oftentimes, customers are working with orchestrating and composing filters. They're doing frontline VisOps things where it's kind of tedious, but you don't necessarily. It's too brittle if you want to automate it in code. So what we did is we just used MCP as a tool to allow LLM vendors to act as a new presentation layer for our platform, and to help you organize all of the data that you have, help you do all of the things that you would normally do in the UI. Just now you can also delegate this to an LLM if you wish. So here I also have another demo. This is just something quick that I set up. This is just Gemini, the Gemini CLI from Google, running an instance of Gemini. Gemini has MCP integration, OpenAI codecs, Claude Code, whatever you use. You can configure OpenFilter MCP. And then with OpenFilter MCP, what I'm now going to try to demonstrate is that it will actually connect to endpoints, like Shalin was showing in his terminal, where it will then be able to go up there and ask our systems to do things on your behalf the same way that you would if you were using the web interface. So it's just gonna, let's test to figure out what video corpora are available in practice. You would probably want to give it some background on which ones you actually cared about. What kind of video do I want? Which test cases are important? What should be foreground? What should be background? And we do have endpoints planned to allow the MCP server to also annotate these videos with sort of supervision about, oh, what did I actually put as the desired subject data? What do I want the pipeline to be able to detect? In which test cases would I like to test regressions against? What? Okay. Oh, it's actually polling. Okay. Well, that's going to run for a while, probably, maybe a couple of minutes. Unfortunately, this is going to be very boring. I'm just going to be sitting here. Oh, okay. Wow, that didn't take too long. Visible in the video corpus means all of this output is a little bit garbled. I'm just going to ask it to do that. In practice, I don't know if we would want platform users doing this, but I also don't have the endpoint in there, so. And there we go. It has downloaded a video that we can now watch. Should we watch it?
Sure.
Where did it just put this? What? Oh no. This is why I don't usually demo, by the way. Good lord.
Did it say in Gemini?
Oh,
10?
it put it in temp. Oh, okay. So. Oh, it's truncated the path. Wow, look at that. Yep, here's what it generated. It also generated, in addition to this Uncanny Valley dog, it also generated some Uncanny Valley audio for us to listen to. Okay, well, I hope that was informative. And, we're just going to keep working to augment the MCP server with all of the capabilities of the platform. This is only one endpoint. And we were hoping to be able to demonstrate all of the same things that you can access through the web UI can also be accessed through LLMs and automated through agents, hopefully in a way that is not particularly fragile, as we just saw the systems are surprisingly adept at adapting to unforeseen circumstances and perturbations, as we saw in this demo. Okay.
Good.
What is
And
there?
yeah, something that I want to really quickly close with was what we have planned for the next coming releases, which is to hook up both of the components that what in terms of what Sam and I showed. Essentially what it would look like once we have the agent hooked up with the MCP filter is that we would start by creating a pipeline using the OpenFilter MCP definition, specify the video source, and then immediately begin the deployment status with the agent, setting the status of the deployment to starting. And this would then tell us when the deployment process has officially begun. At this point, the new deployment agent would take over. The agent would detect the new OpenFilter MCP instance, ensure that there isn't already a deployment for it, and then create a single Kubernetes pipeline run. Instead of just firing off the deployment and moving on, the agent would then actively monitor that filter pipeline run and watch pod readiness, configuration correctness, as well as completed conditions. And the OpenFilter MCP demo at the end, when it works, would just prove that the deployment automation works end to end. A real pipeline will be created, deployed, monitored, and then confirmed automatically. The key difference here is how the OpenFilter MCP works with the deployment agent and how we're able to set the task of owning the lifecycle away to something else, and how the user would not have to see any of this end to end, and that it would just work seamlessly for their side. So when a customer deploys something like the OpenFilter MCP and the deployment agent, they're not just launching infrastructure, they're getting a confirmed running video pipeline with 0 manual steps. And that's all that we have for the demo. And thank you for watching. Thank you for listening. And we hope to have more coming out of the OpenFilter platform very soon.